What's up, guys? Welcome back to another LeetCode. We got another tree problem in front of us, and let's see if we can solve it. So this one is the one right after the last one, and it's called Validate Binary Search Tree. And this one is saying, given the root of a binary tree, determine if that binary tree is a valid binary search tree. And if you've taken any data structures class, this problem statement should be pretty clear, but if you haven't, a binary search tree is a binary tree where at each node, the value to the left is less than the value at that node, and the value to the right is the value greater than that node. And this is like nice for like searching, because if you have, I mean, this isn't valid, so it doesn't work, but like if you were searching for 3 in this tree, that actually wouldn't work because this isn't a valid binary search tree, but you could just check at each level whether that value is greater than or less than that value, and like traverse down the tree to like find your item. It's like a binary search, literally. But anyways, to actually verify this, I mean, it's kind of important to know what it is to begin verifying it. But let's draw out a nice example. I'll do this example that they have for me. 5 goes to 1, goes to 4, goes to 3, goes to 6. Nice. So I'm thinking another search again, or another traversal, because it's a tree problem, and from what I've noticed after solving like 8 of these is the majority of these tree problems are just solved using a depth first search or a breadth first search, and a lot of times you can actually solve it with both, and in that case you want to do it with the depth first search because it's just easier to write that recursively using the stack, and you don't have to do like that iterative boilerplate. But anyways, I think approaching this with that in mind is good. So I'm gonna do it with a depth first search again, which means you start at the top and you want to check. I don't know. I mean, intuition says you want to check whether the left value is greater than or equal to the current value. Actually, I don't even know what the... Is it greater than or strictly less than? Okay. I guess it's important to read the problem description for stuff like this. At least I did that. Sometimes I don't. But I want to check this. If the left value is less than the current value, less than the right value. And I want to do that at each node, but I think that would cause a problem, because like, let's say, actually this is a good tree to show this, because let's say I did that here. That check would actually pass because 3 is less than 4, less than 6, right? But this is not a valid binary search tree, as we saw with, like, in the problem statement and when I tried to run something through it, because this 3 should be on, or no, because this 4 is in the wrong spot. Yeah, this wouldn't work here, but here it would work. Like, there's scenarios like that. If you just check, like, isolate these, like, subtrees, you run into those kinds of issues. So I think what we need to do is, when we go a direction in the tree, we need to maintain like a right max and a left max is kind of what I'm thinking. Because I mean, here on this tree would break right away. Let me see if I can come up with a better tree for this. I want one that breaks like a level deep, because I think that's the hardest case to catch. So let's say this is 6 here. Yeah, if this was a 4, this would be a little difficult. Because if you do this check, that's like the immediate check everyone would think of. It's the first one I tried when I attempted to solve this like before Thanksgiving break. You get to this node, and that check's like, yeah, we're good. But this 4 should actually be on this side. The 4 should be like here if it was added as the last node on the tree. So I think you need to maintain some sort of like left max, right max. Because if you're going to the right, you know the min. I guess it's min max. So maybe like we could write it like this. You know the min is 5. And the max is 6. Here, let me start something here actually. We're going to start a traversal at the top of the tree. And we'll set it so the min is negative infinity and the top is infinity. You go right, and then we're going to change something. When you go right, you know it has to be greater than 5. Everything that comes to the right side has to be greater than 5. So we're going to update it to 5 and infinity. If it's within, we check if it's within these bounds. And you go right, and you want to change the left value again. So then you set this to 6 infinity, and this also passes. But then let's say here you go to the left, and now you know the maximum this can be actually is 5. So then you set the 5 on this side. And here you want to set the left is already 5, and you want to set the right to 6. So that's how you know that this is wrong. And this actually doesn't work. Whereas the rest of these pass. So I like that intuition. It's better than the level by level check. So let's dive into the code. We're doing another DFS, so probably gonna need that. We wanna set up some boilerplate for that. So it's just a binary tree, so we can just check if there's a left child, then we wanna traverse there, and if there's a right child, then we wanna traverse there. But then we actually have to do something inside the DFS, which is always the hardest part. So at each node we want an interval, and we want that interval to change. One of the harder parts about these tree problems is knowing whether you want like a global variable, like a count, or if you want some sort of variable or data that is different on each layer. Like whether you go left or right, even though it's one layer deep, the interval you're searching for is much different. So I think actually we need this up here, min and max. I don't like that though. I think those are reserved. We'll just go... No, left and right are also reserved. Cur min, cur max, sure. So we have that, and we want to check immediately if cur min is less than cur val is less than cur max. And if that's right, we're good. But if it's not right, we're not good, and we just want to return false. So I'm trying to decide whether I want to actually check the opposite of that. So if I did something like this, and I don't know what to do inside of this function right now, I'm not gonna lie, but sometimes looking outside the function will help you with that. So what would I do if I had a working DFS? I would need to call it, obviously, with the root, and I would want like a float of that and that. But I can't just call it because I need to return something, so I gotta return here. So then when I'm doing my recursive calls, I actually need to return here too. But I kind of want to return in one go, I think. Like, because I've run into this problem before. When I'm doing the returns and I have like a split statement here, and I try and return something, like, let's say it's good for all of this, like it'll just go left and it'll be like true, and it'll come all the way up and it'll just return true. When like really the problem was on the right side, it'll never even get over here. So like I need like a proper base case. And I think I need these in one statement. But I also need to change the current min and the current max, which might depend on which direction I'm going, so that's a little confusing for me. And also there are the cases where like there is no right child, or there is no left child. Well, let me go back to this. So, we enter the top, and we set this, and I know that those are set. And we have those just at that layer as kermin and kermax. And then I need to go either left or right, and update. If I go left, I want to update the right one here. Let me just... This might still be an issue, but I'm gonna go back on what I just said for the last like 5 minutes, and I'm gonna solve one problem at a time. So I'm gonna set this. So if I go left, the kermin is just what kermin was. But cur right is the current value that we're at. And then if I go right, I think I said that wrong. If you go left, this is what you do. And if you go right, then the minimum value becomes the current value at that node. And then you just carry on the max. This is true. But I also have to... Or no, I don't have to update kermin and max, because that's how I update it. I only update one at a time, and I do it like within the function call. So I just need to check whether at any node is the current value within the min and max. But I don't know if I want to check whether this is true or check whether this is false. If I do true, then it will go through and it'll all be true. Or maybe I do both actually. Maybe that was a brain fart. If it's this, it's true, and if it's that, it's false. and then we return them up, I'm gonna submit this, and I think it's gonna like half work. Because like sometimes, yeah, I've run into this many times for me to remember. Enough times for me to remember it. So this is saying true because it just goes down. It was only going down the left side. It's never like getting to the right side because I have this function and then I hit left child and I have this function. I hit it, and then eventually I get to a base case because I'm either returning true or false. And when I get to the bottom, I just send that up. So on this case 2, I'm giving true because I go from 5 to 1, and it's like, oh, you're good, bro. It's true. I need to do, I don't know, now but I think it's gonna break if I don't have like a check for the children, but I need to like combine these two into like one return statement. Well, that's still answered true. Maybe it's or, because if... No. No, it would be and. I just don't know how to handle the children. I believe in my check here that if it's within the bounds, that node is good, and if it's not within the bounds, the node is bad. Maybe I do like maybe I do it up here. So if there's no left child, let me just run through what my algorithm is doing right now on this tree, the old tree. I need some more space. We're going through test case. Okay, so we got the 5, 1, 4, 3, 6. So right now I'm doing negative infinity to infinity. And I check whether it's within that, so I return true. I have true here. Oh, is that why? Everything's just returning true because I just returned something immediately? What, do I have to go like deep in first? And then do my check? What would this do? This would just send it down. I don't know the particular, like whether it executes these at the same time or if it does one and then the other. I think it would have to do them at the same time. It would go down to the left side, and the thing would become so this would just set all of the bounds. This would go current min is the min and the max is 5. It would do this. It would do this. And it would just keep going down. The min is the current min, which it thinks is. When you go left, it thinks it's 5. Even though, I mean, we obviously can see this is not a binary tree, but that's what it's doing. And it thinks the min is 5, because that's the root node. And it would go 6 here. Okay, so yeah, so it doesn't actually do any true check. What? What is that? It doesn't do any checks, what this is doing. So it just goes through and it sets all of the things. And then it only when all the functions are called with all the parameters, then do we go through and we check. Yes. We like return that. Yes, we turn that up. And then we go false, and then that would propagate up to the main return, like it would. Well, I can talk all this hullabaloo, but let's see what happens. Okay. So now we're reaching an actual issue. Which is, it's trying to go to a child that doesn't exist, actually. So it's getting to the bottom. Can I just do... Can I do that? Or do I have to do each child individually? I don't know. I'm gonna check. Now I'm just getting null. As it goes down, that's just the one it returns. That just return true for each one? I really don't know. Yeah, it will. Okay. Then this will break on cases where there's only one child. Yeah, it should work on this, but if I submit it, it's not gonna work. They're gonna find one where it's not gonna work. Yeah, okay. I would have been very upset if this did work here. I wish I could see this tree. It's just saying, or it's probably built in. Okay. So this is a tree where it's 1 1. Let me look at this tree. So it's 1 1, and we get up here and we have our bounds. But immediately I try and return this, which goes here. It doesn't have both children, so it goes here. And then it just returns true, even though it's not true because these two are equal values. Because I didn't set the proper thing. What if I just hit all the cases though? What if there's only this or only that? So there's only left, you only go left. And if it's only right, you only go right. This might work. So I'm just trying to set all my bounds. This doesn't work. Oh, it's probably doing the same thing where I like have... So I can't do the check here. I can't. No, I can't do it. Because it's just doing this one, getting down to my base case, and then returning that. I actually almost did get through. There's only five cases left, I guess. Let me go back to the other one. You can see I did actually solve the problem, but I just used the LeetCode video, and that doesn't That doesn't always work all the time. I don't want to relook at that solution. I like this. I think it might have to be done there, because I need to check. I want to do this check. I just don't know what to do if the child doesn't exist. Is my main issue right now. Let me think about this. So I'm going through and I have the current value, so it just returns true immediately. But then it does actually go left, resets all of them, and checks, so it should return false here. But then when it gets down, it assigns true here, then it goes here, and it's negative infinity. 1, yeah. And then assigns false. But then it'll try and do it again, is the problem. It'll get down to this return statement. And there's nothing. And I can't only execute this when there's... Yeah, because then I just, like, go back to my old error. If not. So these don't exist. Dude, I don't know what to do about these cases. I can do this, but we've already done this. I don't think it's gonna work. It's gonna return null. Yeah, any case where there's no, where it's not like a completely even tree, or a completely complete tree. Because it goes to the left. It says there's no left child. And that's just what it returns. Oh, I'm so stuck on this. Well, if there's no... If there's none of, like, either of them, then it's fine. But if there's not only one, I don't know what to do. Because I don't think I can just return false. That doesn't even make sense. It works on these, like, out of coincidence. How is this even outputting true? Is this always doing that? What? It's just doing the check. It does it here. Does it here? It should just fail here. It should go down and then. I want to get this without looking at something. I really do. But I don't know. I don't know what to do when I've hit a roadblock like this. I check one of the nodes. And if it's right, I do this, and if it's false, then I just send that back up, and if it's ever false, that should work. And it would have to always be true for it to be true. I believe in this, and I believe in this. And this is my, like, doing something. I don't know, maybe another approach. I don't know if this is how you're supposed to do it, but what if we just set self.valid to false? Or to true. Always assume that the tree is good. And then, I'll just do this for now. If it's ever not good, then return false. Well, don't return false, set self.valid to false. So then I can do the, we can do this. Like if there's ever not a left child. But then I don't have to deal with all these nested like returns, I think. I could just return, like just run this and then return valid. And it'll only run the right one, so if there's no there's no left child, only run the right one, and if there's no right child, only run the left one. It makes more sense to do so. If or but if both of them exist, I gotta write both. So if okay. This could work. I'm not returning anything, but I guess I gotta check if cur.right and not cur.left and not. If neither of those cases are true, then I run both of them. Really? Saying we've gotten down to a node that doesn't exist. If the right exists, then I send the right. If the left exists, then I send the left. if they both exist, then I do both of them. Okay, there we go. I had to like really spell it out for them. This should actually work now. I was just getting mixed up with all the nested return. Wrong answer. Alright. What is this? This game added this 3? How did it pass all the other ones? Does this affect it? Do I just have to do that? Oh, that actually did affect it. I gotta read into like the... Yeah, I discovered a weakness. Wow. I don't know how like the doing the Boolean operators on nested functions, like how that actually executes. I don't know how to return up. Yeah, I passed. Is my solution not optimal or something? How do I see my... I feel like I should have optimal runtime. Because I only do one DFS. Like, I have it written out really weird, but... Let me look at the solution I did when I was following along the video. Yeah, that was there. 3 milliseconds versus 0 milliseconds? What did I even do that was different? Oh. I can only have one base case. I was like returning things. Oh, the base case is when you get to the bottom of the tree. Then you know it's good. If you get all the way to the bottom. Actually, I did a different check here. No, that's fine. But it's just, you see just one return, then you go in here, one return of function calls, and then one spot where you actually like return a real thing. Because like since like if you have a return, it's gonna return like an actual value eventually. And like if it returns an actual value eventually, that's the value it's returning. That's why if I split it up into, like when I had this, when I was trying to check the children this way and I had the return attached here, that didn't work. But I want to see if this is... if this is decent complexity. Wow. All of this just a one prompt. Just a one prompt the answer. Wow. I can't believe it. Alright, come on. Analyze the image, bro. Let me end my pain and suffering. What are you thinking about, bro? Nah, you got it. I was cropping it, too. Okay, cool. That's what I thought. I just assume there's, like, more branches, I guess, so... yeah, maybe that. Oh, okay, no, I see. This one will run through the whole tree no matter what. And that's why it's longer. This other solution, the better solution, will stop immediately as soon as it finds it. Okay, this is a good exercise, but I'm done with this. Goodbye, until next time.